Elon Musk has finally addressed the growing controversy surrounding the object known as 3I Atlas, and what he revealed has sent shockwaves through the scientific community. Drawing directly from tracking information gathered by SpaceX's vast satellite infrastructure, Musk disclosed observations that stand in stark opposition to NASA's official narrative. According to him, the behavior of Atlas cannot be reconciled with publicly released explanations, and the data suggests something far more complex and unsettling than previously acknowledged. In a series of direct and unusually candid posts on social media, Musk released portions of tracking data collected by SpaceX's satellite network. This information indicates that Atlas has been performing maneuvers that NASA has never openly discussed. Musk's conclusion was blunt and unsettling. The object appears to be operating in ways that defy the current laws of physics as humanity understands them. He emphasized that NASA is fully aware of these anomalies, yet has chosen not to address them publicly. That silence, he argued, is deeply concerning. More troubling still is the implication that government agencies may be withholding information about the true nature of what is moving through our solar system. What makes Musk's disclosure particularly explosive is the scale and capability of SpaceX's observational infrastructure. SpaceX currently operates more than 5,000 Starlink satellites, each equipped with sensors designed to continuously monitor space. This massive network forms one of the most comprehensive real-time observation systems ever deployed. When such a system detects behavior described as impossible by conventional standards, and when those findings are met with silence from official agencies, it inevitably raises serious questions about what Atlas actually is. The information revealed through Starlink's data paints a far more alarming picture than anything found in official statements. NASA's lack of response, according to Musk, speaks volumes. In this case, silence may be more revealing than any carefully worded press conference. To understand why, it is necessary to examine exactly what the Starlink data shows about Atlas's behavior, because these observations fundamentally challenge our understanding of the object itself. Over the past 6 weeks alone, Atlas has executed no fewer than 47 distinct course corrections. These movements are not minor deviations or errors caused by gravitational drift or measurement inaccuracies. Each adjustment represents an intentional maneuver, changes in velocity and direction that indicate active propulsion. The data shows clear acceleration profiles, precise directional shifts, and carefully timed actions that point to calculated navigation rather than random motion. An orbital mechanics specialist who reviewed the data was unequivocal in their assessment. According to this expert, the evidence is definitive. These are spacecraft-style maneuvers. The changes in velocity require thrust, the alterations in direction demand guidance systems, and the precise timing implies mission planning. Natural objects, such as asteroids or comets, simply do not behave this way. Yet Atlas does. And even more concerning than the maneuvers themselves is the apparent purpose behind them. The course corrections follow a deliberate pattern. Atlas is not moving randomly through space. It is positioning itself to optimally observe the inner planets of our solar system. It spent 3 days studying Venus from carefully calculated positions, then shifted focus to Mars, where it maintained specific geometric relationships with the planet for nearly a full week. Now, it is adjusting its trajectory once again, this time to enable comprehensive observation of Earth, using the same precise and methodical strategy. The energy required to perform these actions is staggering. 47 powered maneuvers would drain the energy reserves of any spacecraft currently built by humanity. Yet Atlas continues to maneuver without any detectable loss of capability. There are no signs of power degradation, no reduction in performance. Whatever energy system Atlas uses operates at levels far beyond modern human technology. Even more remarkable is Atlas's apparent ability to respond dynamically to its environment. When a coronal mass ejection erupted from the Sun, Atlas detected the event and altered its trajectory before the incoming plasma wave could strike it. This reaction would require environmental sensors, threat assessment systems, and autonomous decision-making processes. Crucially, all of this occurred without external control. Due to the limits imposed by the speed of light, real-time remote operation would be impossible. The decision had to be made on board. Perhaps the most disturbing aspect of Atlas's behavior is evidence that it is learning. Early maneuvers were less efficient, consuming more energy than later ones. Over time, the object adapted to the conditions of the solar system, refining its navigation techniques and improving efficiency. This is not the result of fixed programming. It is adaptive behavior, artificial intelligence functioning on an interstellar platform. When analysts examined Atlas's trajectory in detail, another unsettling pattern emerged. The object is not simply passing through our solar system. It is conducting a systematic reconnaissance mission. Its path maximizes the collection of intelligence about the inner planets. Atlas approached Venus from an angle that allowed optimal atmospheric observation, holding its position for a full 72 hours. During that time, it transmitted intense electromagnetic signals, actively scanning both the planet's surface and atmosphere. From there, Atlas executed a precisely calculated maneuver toward Mars, following a minimum energy trajectory that any human spacecraft designer would recognize as optimal. Upon arrival, the pattern repeated, but with greater complexity. Atlas surveyed Mars from multiple angles, deployed smaller objects onto the Martian surface, and spent 6 days collecting data before departing. The thoroughness of this operation suggests that Mars was of particular interest or importance to its mission. Now, Atlas is approaching Earth using the same systematic methodology. Its current trajectory is being adjusted to provide unobstructed views of our planet from multiple vantage points. The data shows that it intends to observe Earth more intensively than it did Venus or Mars. This could mean that Earth is the primary objective of the mission, or that our planet presents more complex analytical challenges requiring deeper study. An intelligence analyst who reviewed the overall pattern described it as textbook reconnaissance. The approach is methodical. Systematically observe each target, gather comprehensive data, prioritize resources based on perceived significance, and adjust mission parameters in response to findings. By this definition, Atlas is executing professional intelligence gathering operations on an interstellar scale. The electromagnetic emissions from Atlas further reinforce this conclusion. Early in its journey, its transmissions were exploratory, cycling through different frequencies and communication protocols. Over time, these emissions became more focused and deliberate. Current signals indicate active sensor scanning using refined techniques developed through experience within our solar system. Atlas has also demonstrated the ability to deploy and maintain auxiliary assets. The dozens of smaller objects released during its encounter with Mars remain active and continue transmitting data. In effect, Atlas is constructing a surveillance network across the inner solar system, establishing permanent observation points that will keep gathering intelligence long after the primary object moves on. One of the deepest mysteries surrounding Atlas is how it sustains such extensive operations without apparent limits on power. Recent observations are beginning to shed light on an energy system that challenges fundamental assumptions in physics. Atlas has completed 47 powered maneuvers, transmitted vast quantities of electromagnetic signals, operated advanced sensors continuously, and maintained full operational capability for months. At no point has any degradation been detected. The total energy expenditure involved exceeds what even the most advanced human spacecraft could sustain, by orders of magnitude. A propulsion engineer on Earth analyzed the data and concluded that known technologies cannot account for this performance. If Atlas relied on chemical rockets, the required fuel mass would exceed the object's entire size. Even ion propulsion systems, among the most efficient we possess, would have exhausted their reserves weeks ago. Solar panels alone could not generate enough power to support the observed maneuvers. Simply put, the energy budget does not work using any technology currently available to humanity. However, emerging evidence suggests that Atlas may be harvesting energy directly from its environment. During periods of heightened solar activity, its power signatures increase. This implies that it may be collecting energy from solar radiation or from charged particles in the solar wind, effectively refueling itself continuously. Such a capability would explain its seemingly limitless operational endurance. If Atlas can extract usable energy from ambient space conditions, it would never truly run out of power. It would function like a spacecraft fueled by sunlight, solar wind, and cosmic radiation, resources available almost everywhere in space. Yet even this does not fully explain the mystery. because the object also demonstrates the ability to store enormous amounts of energy. Atlas generates massive power spikes during maneuvers, indicating the presence of energy reserves accumulated over time. Whatever storage system it employs has an energy density far beyond that of the most advanced batteries or capacitors developed by humans. This is technology that, if understood, could revolutionize not only spaceflight but all energy infrastructure on Earth. Perhaps the most profound revelation contained in the tracking data is confirmation that Atlas operates using highly advanced artificial intelligence. The patterns in its behavior leave little room for alternative explanations. Atlas makes autonomous decisions in response to changing conditions. When it detected the coronal mass ejection, it assessed the threat, calculated the optimal evasive trajectory, and executed the maneuver within a time frame that makes remote human control impossible. This is onboard AI acting independently. The evidence of learning is even more compelling. As Atlas moved through the solar system, its navigation efficiency steadily improved. Early maneuvers were energy-intensive. Later ones achieved the same outcomes with significantly less thrust. The object learned from experience, refining its methods through trial and adaptation. This is machine learning in action. An artificial intelligence researcher who examined the data described the system as highly advanced. According to their assessment, Atlas demonstrates AI capable of long-term autonomous operation, environmental adaptation, experiential learning, and performance optimization. This approaches the level of general artificial intelligence that humanity is still struggling to develop, and Atlas is deploying it across interstellar distances. The reconnaissance mission itself shows evidence of adaptive planning. Atlas devoted more time and resources to Mars than to Venus, suggesting that it found Mars more significant and adjusted its schedule accordingly. This is not rigid programming following a fixed sequence. It is flexible mission execution, guided by discoveries made along the way. Even Atlas's sensor systems exhibit learning behavior. Early electromagnetic scans used broad-spectrum methods. Over time, the scans became narrower and more precise, targeting specific frequencies and data types. This refinement indicates an understanding of what information is most valuable and how best to acquire it. This goes far beyond automation. Atlas observes its environment, analyzes data, learns from outcomes, and adapts its behavior to improve results. Whatever intelligence designed and launched this object created an AI capable of conducting independent interstellar exploration, making mission-critical decisions light years away from its point of origin.